Okay, so I'm sharing my screen again. Let me know when you can see it. Can you see the slideshow?
Yeah, we can see.
Okay, so one thing after the pooling layer. So this is the formula to calculate once you pass an image through a filter of some specific dimension. What is the output dimension of the image? So special size of the output image can be calculated as W minus F plus 2P by S plus 1. Looks like a confusing formula, but it's not. I mean, it's very simple. W is input volume size. Okay, input volume basically is whatever is your dimension of the. We'll just see an example. F is the size of filter. P is the number of padding applied, right? In case you have no padding applied, then P is not needed, and P is 1 actually. And S is the number of strides, right? Now, suppose we have an input image of size 32 into 32 into 3, and we apply 10 convolutional filters of size 3 into 3 into 3. Now, what is the third dimension all about? It's the because it's a colored image, right? Otherwise, it's a 3 into 3 convolution filter with single stride and no zero padding. Okay. So zero padding is not there. So P is equal to 0 actually. So okay. So earlier I said by mistake I said 1. So zero padding is not there. Then your P will be 0. W is 32. That's the size of the image. And F is equal to 3. Why is F equal to 3? Because you have the filters. This X and Y coordinates are 3. Okay. P is 0 because there is no padding, and S is 1 because there is number of strides is 1. It's normal. So output depth will be equal to the number of filters applied, that is 10, as I told you. The third dimension becomes equal to number of convolution filters you're applying. Okay. So then the size of output value volume or size of the output image will be 30 into 30 into 10, 32 minus 3 plus 0 by 1. So it's reduced from 32 to 30, and now the third dimension is not 3, but it's now become equal to the number of filters you applied. Hope this is clear. This is how you get the output from each layer, or like each layers of convolution filters. This is okay, right? Is this okay? Then yeah, okay. Now, Ganesh, you can draw. Yeah, you can drop your hands. That's fine. Thank you. I hope everyone is back now. Amit, Anand. Guru, Kaushik, Amarnath. So I still think a lot of people are not there. Pratik, can you
Yeah,
just message? Pratik,
yeah,
can you
sir.
message them?
Drop a reminder.
Yeah. Because I don't want to miss. Just let's give it a minute then probably. Folks who are there, can you please turn on your camera so that I can see who is there and not there? I really want to start the class. We have a lot of things to cover.
Yeah.
Thanks, Ganesh.
Guys, please turn on your cameras.
Okay, Shri Valsa is there.
One question while others join, sir.
Yeah. Please go ahead.
Okay, so compared to machine learning, deep learning has simplified a lot of things because the respective libraries take care of the methods take care of a lot of internal things, right? So
Mm-hmm.
the number of lines of code that we write is like very simpler here. So from the innovation perspective, when we want to expand the depth of what we are doing, so how much of the what do I say, the mathematical knowledge is needed behind like for every concept in deep learning here.
Uh, so see, one prerequisite for learning deep learning is you should have knowledge of machine learning. Okay, and and you should have knowledge of I mean basic algebraic knowledge from say high school or maybe intermediate school, right? And that's basically what is required because see deep learning, how weights are trained exactly and implementing from scratch you can learn, but nowadays most of the deep learning modules like keras or libraries like keras hide that complexity from you. So you just need to understand what is happening. So for in this case you now understand what is a convolution neural network, how it is happening. Now all these things of creating the filter size and other things, or like initializing the filter weights and other things are not are taken care of by keras itself, right? But you just have to understand that this is what is happening under the hood. So again, in terms of mathematics, this definitely I would recommend people to have a basic background of machine learning first on what is happening in terms of loss function. How do you train a model and what is the gradient and other things, right? So those kind of things are required for sure. That's the amount of mathematics I think will be required here. And that mathematics, many of us have the background probably in high school or maybe during our graduate courses. So it's not very different, but definitely you should know that in order to appreciate it fully. But as I said, keras takes away a lot of complexity in terms of you don't have to implement it from scratch.
Yeah, when I do that, like I have some kind of a withdrawal symptom because having implemented a lot of steps in the machine learning, right? I mean, we write a lot of code there, but here it has oversimplified. So that is giving some kind of withdrawal symptoms. I was wondering whether
No,
should we.
but this is like see again the I mean this is like we are looking at simple code to write train a model for identifying images. But a complex machine vision problem, you can make your code complex to solve the whole business problem. Identifying a image thing is taken care of by this code. I mean, this 5-10 lines of code, right? So you can focus your complexity on maybe creating a combined system which is very complex. So maybe you are taking a input from a text field as well as a machine vision image field, and then your model is doing that thing, right? So that complexity you need to design. Underlying image and text reading, and I mean underlying text and image model basic architecture is taken care of by keras. So I mean imagine if even that you had to apply, then it would have been a lot of work for you. You will have to first create a from scratch a text mining model in deep learning. Then you have to create from scratch a machine vision model, and then you'll have to then combine both of them to read both the data and then combine something, right? So here that work which was not required initially is now handled by keras, and you are just focusing on combining them in the best possible way.
Okay, sure, sir.
Sir, I guess we have everyone now. We can start
Okay,
this.
thank you. So I'll just repeat this because I think very few people were there 5 minutes back, 5-10 minutes back. So spatial size of the output images is given by a formula. Now, what is this? What is it that I'm discussing here? This is the input image 32 into 3, and you pass it through 10 filters, each filter of the size 5 into 5 into 3. Then how did we reach 28 into 28 into 10? That's this formula is talking about. So the output size is W minus F plus 2P by S plus 1. W is the input image size, or F is the size of filter. P is the number of padding applied. If it is zero padding, if there is no padding applied, then P will be zero. And S is the number of strides. If it is one stride normal, it will be one only. So if the input size is 32 into 32 to 3, the last slide, we apply 10 filters of size 3 into 3 into 3. So filter is nothing but your convolutional filter with single stride and no zero padding. Then W is equal to 32 because your input image is 32 into 32. F is 3 because your convolution filter is 3 into 3. P is 0 because there is no padding, and S is 1, stride is 1. Then you reach this. Therefore, the output volume will be 30 into 30 into 1 from 32 into 30 into 3, right? So that's how you have reduced two of the dimensions, and one of the dimensions has become equal to the number of filters you applied, right? So now if you further apply this formula in like you apply 10 more layers of 3 into 3 into 3 this filters, 10 more layers of 3 into 3 convolution filters, what will be the size of the next output? Can somebody tell me?
Sir, repeat the question once.
So this first layer, the output is 30 into 30 into 10 because of the formula. Now if I apply 10 more filters in the next layer of size 3 into 3 into 3 to this, what will be the output based on this formula? Size will be W will be 30, correct? F will be 3 again, correct? Because F is again this filter convolution filter size is 3. What will be P here? P is again 0. I'm not doing any padding. S is 1, right? So it will simply reduce by 30 minus 3. So it will become 27 plus 1, sorry. So it will become 28. Okay. And this layer will be number of filters applied. So it will become now equal to the number of layers. It will be added. It will become 20. Okay.
Yes, sir.
Okay, so your this third layer is increasing, becoming equal to the number of filters you applied, and this X and Y keeps on decreasing till the end. You are maybe left with. So typically, in the end, after applying so many this convolution and max pooling layer, you might be left with something like output of 5 into 5 image size, and maybe the third layer is 512. Okay. Why 512? Because you applied so many convolution filters in front of it. Okay. Sorry, to process it. And you are left with just 5 into 5 main image size. Okay. Now you can just straighten it out and connect it to a dense network like in the next slide. You can straighten this out, connect to a dense layer, and then just feed it to a model which can predict whatever number of classes you want to predict. So this is in a way, and as I said, convolution layer helps in extracting features. As we go deeper in the network, the more specific features are extracted as compared to a shallow network where the features extracted are more generic. The output layer in a CNN, shallow layer means in the first two layers, maybe first few layers, the features are more generic, right? So for example, if you are learning to classify a horse, it might classify any kind of, I mean, horse family itself, right? But specific in the end, if you are only classifying maybe horses from say Netherlands or whatever from Middle East, then in the end these features will be very specific to a Middle East kind of horse, right? But this will be maybe a generic horse and the horse family itself. Okay. Hope this concept is clear. The deeper you go, the deeper the feature becomes to the very specific feature to your problem are learned here. Once you go deep, here its generic features are learned. Okay. Please keep this in mind.
But
We'll use this concept. Yeah.
sir, but if the number of filter you increase, it will take more time to learn, no?
No, in the thing is your you are increasing the filter because you are learning more finer features, right? So the cost of the time taken to train this is much lower than the benefit you get by accurately identifying. So this cost is acceptable. Okay. Cost of
Mm-hmm.
training. So and also to your point, nowadays, as I said, see, compared to 89 when Jan LeCun did his first experiment, our hardware is now very powerful. On your machine, you can. I think some of us in our machines can train a VGG16 model, which is a pre-trained model, which has I think around 20, 25 or whatever 15, 20 layers minimum. I don't remember the exact number, but it's so that kind of machine model can be trained in our machines as well nowadays. So that's why it is not so costly anymore. And the benefit you get with this kind of architecture is too good. Your accuracy. So there is this famous competition which happens, and there, like I think 2012 or 2014, I don't remember. 2012 ImageNet competition. ImageNet, they used CNN the first time 8 years back, and it beat the benchmark for humans as well. So it gave an accuracy, I think, of 95 or 96%. And traditional machine learning models like SVM and others were still in the 80s. So that's when people left them. I mean, people abandoned traditional machine learning models and deep learning started to explode 8 years back because of that competition result. And now I don't think anybody uses anything apart from deep learning in machine vision. So machine vision is completely deep learning nowadays. Nobody uses anything else. Okay, makes sense?
Right, sir. Sir, just once again, in the previous slide, you mentioned 5 by 5 by 512, no? So
Hmm.
that means if I apply this on 32, 32, 3, so the final layer will be 32 minus 5. That means 20 again.
So,
Plus 1,
yeah, no, you will see this 5
28,
by 5 is the
5,
last
12,
layer.
no?
Sorry, 5 by 5 is the last layer. So you can only apply convolution filter with 3 into 3. You cannot apply convolution layer with 10 into 10, right? Because it won't make sense. You are trying to convolute an image which is smaller than your filter itself. That won't make sense, no? So if your final, so for example, 5 into 5 is maybe something here, output here. Now, if you want to put one more convolution layer here, then it is 3 by 3, then it will become 5 minus 3 plus 1, okay, which will be 1 into whatever your number of filters you will be adding here, right? So
Yeah,
that's
yeah,
what
yeah.
will happen. Okay.
Yeah. I'm saying that 32, 32, 3, and
Hmm.
my filter is 512, 512. That way I was thinking.
No, but
So,
okay, you can do that, but we normally don't. We increase the filters. Again, a best practice, we increase the number of filters as we go deeper into the network. Okay. We start with probably maybe at 32, 64, 128, 512, power of 2. Okay.
okay, sir.
We will see examples. Well, again, this is best practice. You can try doing that, but the models learning are best when you increase the number of layers in powers of 2. Okay. So this is what a typical CNN network looks like. As I told you, this was the end of CNN theory portion. We will do some CNN questions now. We have this dogs versus cats data set. Actually, this will take some time to upload. Anybody who has anybody, I mean, we need to run the model and we'll do these steps. So let me just. So we will let me share the link with all of you.
Sir, have you also shared the slides?
Yes, I have shared. Sorry, this is a film.
Yeah, it's uploaded on the LMS too. You can check it under in-class materials.
Okay.
So if you see this is a very famous example. I really start the CNN class with this only for the, I mean, any class I do. So it was done like 9 years ago, but it's very good for learning the concepts. Can you download this data set? And we will not use the entire, sorry, we'll not use the entire data for this. We'll just use maybe 2000 of it. And we will use whatever is given in the Francois Chole's book, the latest Keras using that, right? So can you just kindly download it and we'll run this particular code. I'm sharing the code as well, the link. Okay, by the way, sorry, one more thing before what we are trying to do here is we'll do the following things in the class today. and we will learn each of them very, very carefully. Even though if some portion of today's class spills over in the next class, I'm fine with it. We can do semantic segmentation in detail next class, but today we'll have to be, what I'll be teaching you is, given a classification problem, image classification problem where you need to classify it's what kind of image it is. You start with a basic convolutional neural network. In short, we call it convnet. You then improve the results using data augmentation. Then you further improve the result using a pre-trained convolute like VGG16, which is a very, very powerful. I mean, again, it's like a trained on millions of images. You can use a pre-trained model by doing feature extraction and fine tuning. So that's these are the 4 basic techniques we'll be using to improve our results. You will see that your results improve from 75 or whatever, maybe starting with in the 70s, your accuracy will be there until here you will start hitting almost 90. That's an amazing accuracy lift. So whatever you learn in these 4 steps will be useful in future for any classification problem you do. You can move to further in any of these, I mean, take these steps in sequence if you want to keep improving. And if the very first step you are getting very decent accuracy, you don't want to do the next step, that's fine with us. But if you want to keep on improving, these are the options you have. Okay. Hope that is clear. So let me share the screen while we'll do the first one. Can everybody download the dataset, please, from the link I've shared? Please find the code here. And I would request one of you to volunteer for running this set of codes. In that code itself, they have this code of downloading from external sources. That code you can ignore. You can just upload 2000 images. Can somebody share their screen, please, with the code I've shared?
So I'm facing some issue with the internet. It seems on my laptop, so someone else can proceed.
Okay. Somebody please share. Can somebody volunteer? And rest all people have to do it on their system.
Hey guys, anyone please share your screen?
Okay, I'll volunteer someone. Amrit, can you please share your screen?
Yes.
Okay.
So actually, I opened one notebook. I don't know if this is the right one or not.
Actually, this is Kaggle one. This is next step to what I was discovering. If you can open the folder, the link I've shared.
Just 1 second.
Yeah, in the chat I have shared one link.
Okay, actually, I have two Teams chats, so just give me a minute.
No problem.
One
No
is the
problem.
office.
No problem.
It's also shared on the WhatsApp. You can check the unofficial group.
Yeah, it's open.
Yeah. So in the book of Francois Cholet, this is chapter number 8.
Okay.
So
Sorry,
there,
it
if you
got closed. Okay.
yeah, so it is, by the way, it is for TensorFlow 2.6. I don't think TensorFlow 3 has not come in, right? It's still 2.x, right? The last I checked. So yeah, this should be fine. So this is fine. Don't, you can ignore this one. Just take the first two lines, the TensorFlow import keras and TensorFlow import layers, nothing else. No, not yeah, that's the two lines, and you can create your own Google, I mean collab, or if you're running locally, that's fine with me as well. You can just say CNN cats and dogs, whatever the name of the exercise.
Sure.
Yeah, you can go back to the GitHub link. I hope everyone is doing this. Let me know if anybody is facing any issues.
Sorry, just 1 second. Yeah.
No problem. No problem.
Yeah. So what next? Should I copy this one?
Yeah, no, not that one. Sorry, go down. You will have a small data set. That's just the initial examples in the book. Evaluating convolution operations. That's fine. Max pooling. Yeah, this is the one. So everyone who is following this on the screen, training a convolution from scratch on a small data set is the one. So they are actually downloading the from Kaggle command. I think we can upload manually. So this is what they're doing. They're making a new. They are making this new folder called cats versus dogs small on your local system, and they're copying, creating two folders, three folders, train validation test, and they're copying around, I think, yeah, around 1,000, 1,500, yeah, 1,000 in the train folder images, 500 in the validation, and 500 and 1,000 in the test folder. So they are taking 2,500 images each. Okay, so do you have you already downloaded the cats and dogs dataset from Kaggle?
Yes, I had downloaded. Let me see if
Yeah,
it got downloaded or not.
just see if how many images it has. I think it will have more than 20,000 images, but we don't need that kind of.
It got downloaded somewhere. Just 1 second.
No problem, no problem. I think by default, it got it downloaded in downloads folder. Yeah.
Yeah, this is all.
Okay. So one time you upload this, it should be fine. You can save it. Yeah. So if you see cat and dog, there are 12,000 images, but I think you require only yeah, I think yeah, you require only 5,000 images, 2,500 of each. So you can just pick, you can just upload. I think you need to upload it on Kaggle, right? For this,
Need to upload it on
not Kaggle,
Google
sorry, GitHub,
Google
Google
Colab.
Colab,
Right? Google.
Google Colab.
Okay.
Can you
Okay, I will.
upload? Can I? Has anybody already made their smaller folder, uploaded it or something? You can upload the entire data set as well. It will take time. Otherwise, you can just import 2,500 of each or something like that.
Okay.
Let's just see how much time it is taking. You can unarchive that in the Google Colab once you upload.
I think it is possible to unarchive.
Okay, that's fine. Anybody for whom the data is already uploaded?
I think it's going to take long time for uploading.
Yeah. So can we like maybe do it with
Anybody doing on Jupyter Notebook probably can.
a local
Can we directly
local machine
do
who
on
is
the
doing?
Kaggle?
Yeah,
Can we
you can
do
do
it
it on
directly on the
Kaggle.
Kaggle?
Yeah, please do it on Kaggle. I'm fine with it. I mean, I'm
Okay.
fine with whatever runs fast. So somebody do. I think one of you was doing on local machine as well, right? Two of the people. Any. Can you just please share your screen? I think yeah, you are doing on Kaggle, right? Yeah, correct. You can do it here. You can use. I think they have given some Kaggle code there to download the data. If
Yeah, it is here.
awesome. Let's just jump to that code where they are creating a train and test folder, and that's it. Amazing. So yeah, everyone, please use Kaggle for this. I think that's very fast.
Understand.
Yeah, yeah. No. Above that, actually. Yeah, above that. Yeah, this is the one. Copying images to training, validation, and test directories. So you'll have to original path will be your train path.
Yeah, I will put the path there.
Thank you.
Amit, you could open one code and just copy and start editing, because I found one code where they are already dividing in the validation and training, and then we
Okay.
can modify our code.
Okay. Can you share it then again?
Okay. So let me know once you can see my screen.
Yeah, sure. I can see it.
Okay, so there was one code I just copy pasted. I mean, I just used edit
Yeah.
and just started running the command. So this is reading the data files, train and test zip folders they are given.
Mm-hmm.
And then this is identifying if the image word has
That's
the
fine.
cat,
Yeah,
whether it's
yeah.
cat or dog.
Correct. That's
And
fine.
then the length of the data, and then in the data
Yeah,
0 to
they are in fact
18,000.
using the entire data set around 25,000, but we are using just 2,500. But that's fine.
So we can reduce it.
Yeah, you
If
can
so,
do
I
that.
can reduce. Yeah.
Yeah. Take it from that code, whatever it's there. I think 1,500 for train, 500 for validation, and 1,000 for test. That's what they are doing. Or you can just let it remain for validation and train. That's fine. Test not required for now. So 2,000 and then 500 for validation, maybe. Yeah, 2,000. Yeah.
And then 2001 to
Yeah. Maybe 2,500 or something.
2000. Now we have. Okay, this will not take one. Okay. Yeah.
Yeah. Maybe there is some overlap there, but no worries. Okay.
No,
That will
does
not
it
take.
say
Yeah, that will
index?
not take. That will not take the last element. So that's fine.
Yeah.
There's no
Yeah.
overlap. Yeah. So
Now
TensorFlow image
I
data.
can delete
See
all this.
again, this code, please ignore. This is the second step. This is augmentation. I will teach augmentation. You can add a code here and then do the rest of the steps actually.
Okay. You can tell me which code I should add now.
Yeah, the one which I've sent the link. Share the link.
This is the same one, GitHub.
Okay, so yeah, so go down please in the scroll down. Max pooling operation. No. Training a convoluted from scratch on a small data set. Go down. Yeah, so in this now you see copying images to training, validation, and test directory. That is what they have done now. They have made these folders and they are reading it from the folders actually. And after that, they are defining this. So right now, whatever you have done is you have created those folders, but in a different way. I think yours is a set of those images. That is fine. We can always use that list in our training model. So we can just do the building the model part here, starting the next one. So I've just pasted there and we'll talk about this in whatever we covered in class. We can understand this model from that. So I want everyone to pay attention on the screen. I just want to explain this model. So this is the first step. Whenever you are giving an image classification problem, the first thing you do is you take a simple convolutional neural network. Why is simple? Because it contains only convolutional network and nothing else. No augmentation. Augmentation is something I'll just teach you after this. So TensorFlow import Keras import layers, that is fine. Those are the two modules within this library. Now, so what is input Keras.input shape? 180 into 180 to 3 is nothing but your image size. Your cat and dog image is 180 into 180 to 3. Your layers rescaling line, this one layers.rescaling you're dividing each pixel value by 255. You're making it standardized. You're making it within 0 and 1 so that your model trains easily. Otherwise, if you keep it between 0 to 255, the model training might take time. Okay, it might take time to converge to weights, right? Now after that line is the main key portion. That's where your first filter, the convolutional 2D, is starting. 32 size, kernel size 3, 32 into 32 into 3, and activation ReLU. Activation is ReLU. So again, as I said, activation, you are free to create your own activation, but 99% of the time, ReLU will work fine with you. This is X. Again, it is joining to the input layer, right? Now, after convolutional, you have a max pooling, pool size 2, X again. Now you are, say, the first you had 32 filters of size 3 into 3. Now the next layer, and you followed it by the max pooling layer. Now, next again, you have 64 filters of size 3 into 3. As I said, it is increasing in the power of 2. Now you again followed it by the pooling, max pooling of size 2. Now you have another 128 filters of size 3 into 3, then followed by a pooling size of 2. Now in the end, you have 256 filters and then a max pooling of size 2. They have added one more filter here in the end, filters 256 again, kernel size 3 activation ReLU. And in the end, once you are sure that you have enough convolution and max pooling layers, you are now free to flatten it. You can just do layers flatten, and the output will be a dense layer with just one output, because this is cat or dog. You just need to predict one class, and activation will be sigmoid, and that's it. Your input will be your inputs, whatever, and output is your outputs, what you just defined. And that's where your model architecture is defined. Any questions on this one?
Yeah, so this
Sir,
max
yeah,
pooling in the pool size, why we are
yeah.
taking always two size? Like we are increasing the filter size.
So pool size 2 again is something which they have started with. That's again, as I said, it works for you in most of the cases. You can play around with. You're free to do that.
Sir, yeah, but I had question on the same line. So here you're saying raised to the power 2, but they're doing multiplication, no? 128 multiplied by 2, then
So I mean,
256.
what I meant was they're also power of 2. No, two table. If you do multiply, it will come, right. 128 256 comes, right. Comes. It is double. I know
I mean,
what you're saying. Yeah, but 2 to the power 5 is 32, right? You agree?
hmm. Yeah. Then
And
to the 6, 64 to the 7 to 128
so
like
so
that. Yeah.
so it is either you increase the power or you multiply it with 2. It's the same thing. We are both talking about the same thing. So you're
Okay.
so they started with 2 to the power 5 and then they went to 2 to the power 8 or 9, whatever, right? That's what they did.
Okay. Got
Yeah.
it, sir. And last thing, what is this flatten do actually?
Flatten is straight line. Now
Oh,
no more convolution. Take it as a straight line. Whatever is left. So if you are left with 5 into 5 into 3, take them all in a straight line. That's it. Flatten. So we can do a model dot summary and we can see it's the same thing what you see here, right? They can, have you run it actually? Yeah. Can you do a model dot summary? Yeah. So if you see, this is the model dot summary. You have, once you do flatten, it becomes, can you multiply this 7 into 7 into 256? You will get, I think, 1,12,544. No. How much is that actually? If you flatten it, the number of nodes will be 9654, 256 into, yeah, 256. Yeah. So that's the, so Amarnath, to your question, that is what flatten means. You have basically just made it straight line, fed it. Okay. And the benefit here is this is like really, it's like a very rich set of features, and now your model will be training on this and it will give you accurate results. If you had done the same thing earlier without doing all this extraction, your model output would have been really poor. You can find it out for yourself. You can remove all those layers, and then you can just keep this flattened layer, and you can see what is your accuracy. Okay, you can do that. I leave it up to you as an exercise. Okay, you understood what I'm saying, right? Don't use any of these convolution layers. Just take input, rescale it, and then pass it on to flatten layer. Then compare it with what we are doing, and you will see the performance difference. Just to convince yourself. Okay. So
And one more,
yeah,
one
yeah,
more
sure, go ahead.
question. Sir, as you're saying that, can you scroll once up while we are doing the convolution? So there you are saying that when you are satisfied that it is the convolution is sufficient. I mean, we have got the enough feature extraction is done, and how do you know? Like how do you arrive at that conclusion? I
Your
still
accuracy will
going,
tell you. Your accuracy will tell you.
but so I have to do multiple times, like hit and try.
Yes,
Like I
yes.
have to do
No easy way. No mathematical formula for that. That you will have to run and find out.
the
So, but
first I'll do. Yeah.
again, rule of thumb, definitely have. So, what is there? I think 3 or 4 pairs are there, right? Convolution and max pooling. Do 3
Hmm.
or 4 pairs minimum for any problem. Then start playing around. So start with this. Don't put just one pair. Put two to 4 pairs. And the more data you have, the more. I mean, sorry, the lesser data you have, definitely 3 to 4 pairs are minimum, right? Maybe with if you have like 1 billion images and it's very simple, straightforward cats and dog, maybe just 2 layers would be sufficient. That's fine. Not 1 million. 1 million is very high. Just saying, maybe if you have 10, maybe 25,000 images, even with 2 pairs of max pooling and convolution max pooling, you should be okay, right? So minimum 2 to 3 layers you have to have. Start with that. Ideally 3. Then play around. Once you have the accuracy validation number, it tells you it is like not good. Then you can add and use other techniques which I'll be telling you. So that's the only way to learn if it is not working. No other way. That is okay.
Yeah, right.
Okay. So then if we can, so Nidhi, can you, yeah, so model compile. See, binary cross entropy same as this sentiment analysis question. RMS prop same as this thing. It's the this optimizer. Matrix is accuracy. Obviously, this is accuracy. So let's see if this works for us. Yeah. Hmm. Yeah, they are now reading from the directory. Maybe we'll have to. Not sure if your earlier code is reading from directory. We can use that same thing to do it here. Batch size 32. I hope everyone understands. It's like every 32 images after they have input, then they will update the parameter of the model. That's the batch size. So if the epoch and if your total set of images is data set size is 2000, then you're within one epoch 2000 by 32 times your model will be updated. Hope that is clear with everyone. Epoch and the batch size difference. Relation, not difference. Relationship between what is a batch size and what is an epoch. I have covered that earlier. So
Sir, will you repeat that once? Epoch I know,
so
batch size I
you
didn't
so,
forget.
yeah, so batch size means, so if you have say 1000 images and your batch size is 10. So when you're running one epoch, every 10 images after you're fed, your model parameter will be updated, weights will be updated. And because you are updating every 10 times, every 10 images, then for 1000 images, it will have updated, it will get updated
100
100
times.
times, 100 times. That's the relationship, batch size and epoch.
What do you advise on this? What should be the batch size
32
ideally
again,
for?
power of 2 is best. 16, 8, 32. Again, the smaller your batch size is, more time it will take for the model to run. Sometimes if you in like if you keep a batch size of 8 versus a batch size of 32, model speed becomes half, even 1/4. So you need to be careful. Just see. But if your accuracy is increasing, then you will have to keep it. No questions there. You understand why time is taken, right? Because you are now updating many more times than like earlier. 32, you are updating every 32 images. Here, 8, you are updating every 8 images. So your model will definitely be slower.
Should not it? Yeah. So I think there should be some. Is it okay? So I was thinking if it is like if I have multiple classes, then probably I can think of minimum less passage. I'm thinking just okay. Like I have multiple. I have not only cat stocks. I have cat stock, rat, speak, all those
Mhm.
things. Or then probably I have smaller batch size. That makes sense. But if it is like only two, no, then I can have
Correct, correct.
like
I
more.
agree with that. I agree with the logic. So complex problem, batch size smaller should be good. I agree with that. That's a good point. Is it working for you, Nidhi, this code?
No, 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 because they have done
Okay,
in a
yes.
different way.
So you can probably, yeah. I mean, can we use their initial code where they are creating paths from the original one, because you already have path in your Kaggle, right?
Can
Yeah,
I run
initial
it
code
here
we need to
directly?
use that.
Anybody who's made that path thing work, and you
Yeah,
already
I
have.
think it is working for me. I just downloaded it into the same folder.
Okay.
So it is working fine
Can
for
you
me.
please share, Guru?
Let me stop sharing.
Thanks. Thanks, Nidhi. So our test is starting in another 11 minutes. We'll continue this discussion. Then after the lunch, we'll come back. I think I'll move one of the things to be covered today, semantic segmentation, to the next class, because we really have to understand this really nicely so that we are all experts by the end of this call in terms of classification and object detection.
Yeah, you're able to see my screen?
Yes, yes. Thanks, Guru. I can see your screen.
Yeah. So this is the model summary and
And you
something
can also
epoxy.
share the code with Pratik. Pratik can upload this code on the LMS as well. Yeah. Okay, Pratik.
So what I did is that okay, this train and the test
Mhm.
folder I have extracted is in the same folder where the code is. That
Okay, okay, okay. So,
Python.
so it's
Yeah. So
yeah.
it worked
That's the
everything.
thing to do. Or you can do the pathing as well. That's fine. Yeah.
Yeah.
And anyway, your is running locally on the system, so you don't have to upload on I mean Colab.
Yeah.
Okay, so this is how it looks once you have created this model and you have compiled. I mean, the model parameters, loss functions, and others have been specified. Then you create this. You tell the model, okay, what is your batch size, and it will tell you, okay, 2 classes of training. I mean, again, 1,000 files for validation and 1,000 files for testing. So I hope everyone is clear about what we are doing here. We are just specifying the training, validation, and test data. Now we'll just see it is doing this NumPy as NP, TensorFlow as TF, random numbers. Again, random numbers for reproducibility. It is just including that. And element in enumerate data set break. Okay, it's making this. Okay, why is it doing all this? It can actually. Okay, so in this step, it is actually converting the images into numbers. Right now, if you if you print your images, it is converting. So can you just print out the numbers just so that we are clear what is happening here in the code? Your data set, can you print out?
So
I don't think head.
Data set will be too huge.
Yeah, maybe you can just maybe do a. It's 1000 into 16. It's okay.
1000 into 16 is directly we can 16,000.
It's already running actually.
Yeah, I think I did a mistake.
No problem. No problem. TF data.
I'll stop it here probably. So you want to print the data set here?
Yes.
It's a tensor.
Okay. By the way, sorry, class. This actually, because this is they are going by book exercises. I don't think these three sections in between are relevant to what we are doing. They
Yeah.
are just this is a specifying example. So I just discovered this is the latest edition of the book. So I mean I have done the old edition, but this is something where just they're just shown to explain. So please ignore this. You can directly go to the callbacks thing. Yeah, this is the one. It's still
But
running for
sir,
you.
I mean, can you explain this piece of code why they are doing this?
I will have to refer the book actually. I can
Okay.
do that because this is so what they have done is in the GitHub, they have just given the code and the book. They said keep the book side by side and read it. So they
Oh,
are
okay.
explaining some, I think, batch concept in there by taking a random set of numbers and then showing you how batch is updated or batch is created. That's what they are doing looks like. That's why I was confused why they are doing it in between when they can directly read it. So this particular example, we'll have to keep the book open and see.
Okay.
Okay.
Yeah. So
Please,
here only
check.
I've changed only epochs here. Earlier it was 30 epochs. Just for the execution purpose, I've changed it to
I
3
mean,
here.
you say even if you do 3, 30, it will be fine because it's like, oh, no, 30 minutes it will take,
Yeah,
66
it will take.
seconds.
Yeah.
Okay. Anybody who's already running this, or maybe just, okay, we are near 1 o'clock. Please run this for all 30 epochs. Everyone, please run
Okay.
this. After lunch, we'll have accuracy because we need to compare accuracy after every change we make in the approach. Okay, so please go ahead and kindly share this data with everyone. Not data, sorry,
Sure,
the
sir. I
code,
will.
so that they
Yeah.
once have uploaded on Collab, they can continue doing it. And I would recommend everyone to maybe save it in Google Drive or something so that you don't accidentally close your Collab and then you have to upload it again. Okay. FYI. So we have.
There is an option to upload to Kaggle, sorry, to GitHub from your Google, this thing, Google from Colab. I think we should
Go
do
ahead.
that.
Go
So,
ahead, do that because I will
yeah.
refer the same data set for 3 or 4 more codes. So if you lose the code and lose the data in between, you will again take half an hour to upload. So please use this time while you are giving the test and having the lunch break to everyone should have uploaded on their Collab the data set, cats and dogs. And Guru, if you can share your code, they can use it for, or you can use the one which the GitHub link for the Collab, Franco actually, you can use that as well. Okay, so let's run this first code for 30 epochs. We'll compare accuracy across everyone. And meanwhile, we can start the test, right, Pratik, at 1 o'clock?
Sure, sir. Sure, sir. I will map it at exactly at 1 o'clock.
Yeah. And then, so best of luck, and we'll meet. I mean, after the test, please take a lunch break, and we'll meet at around 2:30. I'll be there for another 5-10 minutes so that you start the test.
Hey guys, I'll be mapping the quiz in 4 minutes. Like quiz will begin at 1 and it ends at 1:35. Just have given 5 minutes buffer. If you guys are late, you can just attend it. There will be like 30 minutes duration and test will end on its own after 30 minutes.
Where it is available, Pratik?
Yeah, it will be available in quiz section. I will be mapping it now, like after 2 minutes. Yeah, I was set to be mapping it at 1 o'clock. So yeah,
In assignments.
yeah, in assignments.
Okay.
So have we started the test?
Yeah, sir. Quiz is live now. They can start it.
For the quiz, I think everyone has to come on camera, right? In my earlier classes, I think it's the rule. It was a rule.
Okay. Please, everyone, can you switch on your cameras?
Yeah, everyone, irrespective of were you there online or not, I think has to be on camera. So everyone has started the quiz, right? Pratik, anybody absent?
No, sir. There are no absentees today. I can't check who has started the quiz yet.
No worries,
But
no worries. But I mean, I think no, everybody is here, right? So then in that
yeah,
case, everybody
yeah,
would
sir.
have
Today's
started.
session, yeah, everyone was attending it.
That's great. That's great. Thank you. So I would not. I'll just ping you for the questions. I don't want to disturb the students with this thing. So.
Sure, sir. Sure, sir.